After that, we will have a demo market that you can see on the map. It's quite a lot. Now we are here in the cube. The demos here. And you also can walk in the spaces for VR, AR, Team for Hub demos. We also have one EEG demo, and at the same time, also you can see on the schedule between 3 and 3:45 there are two workshops, Figma and Unity, and then between 4 and 4:45 there are also demo market and also workshops in Unity and Figma. It's first come, first serve, so there is no pre-registration for the workshop, so you just can come in and yeah, just take your laptop for Figma or take the laptop from the interaction lab for Unity Figma, for Unity workshop, excuse me, and take your seat there. Yeah, so welcome, and I also would like to start with welcoming from our managing director of the BMS faculty.
Good afternoon, everyone. Welcome to the Inspire and Interact event, hosted by the BMS Lab and the Interaction Lab. My name is Twente Peters, and on behalf of the BMS Faculty Board, I may say we're delighted to have you here today. The BMS and Interaction Lab are places where science and technology come together to support innovative solutions for the challenges of our society, closely linked to the very essence we stand for as a university. This is real-time, high-tech with a human touch. Our event today is designed to showcase some of the exciting possibilities the labs have to offer, as well as to provide you with opportunities to interact with the BMS Lab and Interaction Lab staff and learn more about the support they can provide. We also have a lineup of speakers who will share their experiences and findings on several interesting topics. Of course, I can tell you a lot more about what will happen today. But, like I just said, it's about interacting with the professionals of the lab and like-minded colleagues. So enjoy the event and get inspired.
Yeah, and now we have another person who would like to welcome you. It's Jan-Willem van Klooster, our lab manager. Please say a few words before we start.
Thank you, Christina. Yes, very happy to have you all here. Welcome at the Faculty Lab, the lab where technology meets life. So, and we do this together. The Faculty Lab is also your lab, and together we try to educate the student generation of tomorrow and to make possible cutting edge and state-of-art research. So I'm very happy to have you, and also I would like to thank our neighbors from the Interaction Lab who are so happy to join us today. And also I would like to thank, of course, our own staff, Christina, student assistants, and all my colleagues at the lab for making today possible. So give it up for them, please. I hope you will have a very nice day, and I think it's then time to introduce our first speaker. He used to have slightly longer hair when he was still playing in a rock band, but today he's going to talk about completely something else. Please give it up for Professor Harold Vonkerman.
That's a great introduction, thanks. Thanks for that. So I'm going to tell you about taking the lab outside of the lab, and especially inside of the hospital. Can I have the first slide, or can I do that myself? So my name is Harold Vonkerman, and I'm a rheumatologist at the Spectrum Twente Hospital here in Enschede. Does anybody know what a rheumatologist is? No? Nobody? Yeah? So what we do is we treat patients with inflammation. Usually it's inflammation of the joints. It can be any of the joints in the body, but also different organs, so lungs or kidneys can be involved. And these diseases are autoimmune diseases, so your own immune system, which you use for fighting bacteria and viruses, for some reason starts attacking your own body. And luckily we have lots of medications for that. Medication which are autoantibodies which target this inflammation. They're quite successful, but still they're chronic diseases. So we treat our patients for many, many years, sometimes 10 or 20 years. And I have another job which is here at the university, so I'm based down there somewhere in the corner. I'm with Psychology, Health and Technology department, where I do research. And my line of research is patient-centered health technology. So that's two concepts. First concept is health technology. Does anybody know what health technology is? I guess most of you do. So in medicine we basically have three kinds of technology. We have biomedical technology, which is like making vaccines, but also diagnostics, tests, genetics, genomics. And then we have the medical technology, which is the stuff we use in hospitals, like robots and MRI scans and things like that. And health technology is basically the digitalization of everything we do outside of the hospital. So that's like trying to measure things outside of the hospital, monitoring using smartphones and applications. And that's part of my research concerns that. And the other part is patient-centeredness. So first of all, the health technology, why is that relevant? We know that the demand of care, and excuse me for having a Dutch slide, so the demand for care is really rising. So the population is aging, diseases are treated better, which leads to more patients with more chronic diseases and growing costs. So the demand for care is growing, but at the same time we have a decrease in the possibility of delivering care. So there's less people available, also because of the aging. So the ratio elderly to working population is changing, but also we see that people really want to work shorter hours and maybe don't want to work in a hospital at all. So this leads to a high workload for the people who are already there, and less financial possibilities really leads to an increasing gap. So one of the opportunities we have for maintaining the standard of healthcare that we have is by digitalization, and that's why we are very interested in that. Now the other part was the patient-centeredness, and I think we come from an era where the doctor decided everything and the patient just followed his lead. We're now placing the patient much more central in the equation, because we think that we don't only want to measure the biomedical things. So if you have a high hypertension, you come to me, I give you a pill, you come back after a month and I measure your blood pressure again, you still have hypertension, I add another pill, and so on. That doesn't really work, because in the end the patient isn't really taking the medication. And why not? Because he doesn't have the feeling that he's getting better. So one of the things we're trying to do is actually trying to talk to our patients and actually measuring what getting better means. So we can try to measure and aim our goals at things that are important for patients. So now some examples of the things we took out of the BMS lab into the hospital to reach these goals. So the first thing is the telemonitoring part, where we are trying to deliver care and measure the wellness of our patients at a distance. So one of the things we are doing is using an app with experience sampling methods with which you can measure at a very high frequency things like pain or fatigue or problems that patients have. And this allows being able to track things that happen really fast. So if we give a medication, we start measuring immediately on a daily basis whether the medication has its effect or whether side effects occur. But we can also look for temporal relations, see what follows what. And these kind of relations are really not known, especially for side effects. So we know that some people get side effects. We don't know when and we don't know why. So we're trying to discover these things using technology that's available. I think it's one of the rooms in the back you can visit and you can see these applications. So another thing we're very interested in is pain. Lots of our patients suffer chronic pain. This is one of our associate professors, Peter Tinkloster, and he's actually getting electric shocks, so that's a very nice experiment. But he's in control of that himself, so he can stop the increase of the electric shocks. So we know that people with chronic pain, they have two phenomena. They have allodynia or hyperalgesia. So hyperalgesia is that they feel pain at in a much higher rate than you would expect for the level of intensity. And allodynia means that they start feeling pain at a much lower level of intensity. So something that you would feel as pressure, someone with a pain problem would feel as pain. And we can actually measure that. So we've been measuring that at the hospital. We've been giving our patients these electric shocks and telling them, press the button when it's really uncomfortable. And why are we doing that? We're doing that because we know that if you have this proportionate pain system, that normal painkillers won't work. And we've been exploring different systems that may be used to treat this pain. And one of the things we've come across is virtual reality. So we can use a virtual reality application to deliver different kinds of treatments for pain. Now this might sound really strange, but we know that chronic pain is really complex. So you can give education, you can teach people about why the pain occurs, why it is a chronic pain that they're suffering from. But you can also do EMDR therapy, which is the therapy that psychologists use. Acting commitment therapy, you can use relaxation, distraction, all kinds of things that you can use in virtual reality, and we have some experiments with this now at the hospital. It seems to be quite successful. Another program that we've been using is the Walk in Nature program. It's also a virtual reality program. When I first saw this is a program where you can walk in nature, obviously, but there are also breathing exercises and there's a yoga coach. And when I first saw this, I thought this can be used for patients who have to do regular exercises. So there's a disease called Bechdel disease where patients are really stiff. And one of the things they have to do lifelong exercises. But patients don't do that because it's boring to do exercise by yourself. So they stop doing the exercises. And we think that using a virtual coach and some gaming elements, for instance, they have to chase butterflies, that this will stimulate and help the patients to actually continue their exercises. And this is one of my patients actually in the BMS lab doing an experiment. We're asking him, can you do the exercises and what do you think? Is it something you would be willing to do at home or maybe at a physiotherapist? So we're trying to see if these kind of technology can actually be used in treating people. I'm also very interested in communications, so you might recognize the guy but also the glasses. So that's an eye tracker, and one of the things that we've come across is that there's always a third party in any conversation in a medical setting, and that's the computer. So we have to do lots of administration. And patients often say that that's really annoying and that distracts them from the conversation and decreases the quality. And we thought we may be able to actually measure this. So we're tracking the time that the doctor is actually looking at the patient and not looking at the computer and vice versa, and see if there is any relation with the perceived quality of the consultation. One experiment that we're actually starting now is with Furhead. You might know Furhead, it's a social robot, so that it can mimic emotions and it can be connected to ChatGPT, so you can actually retrieve information. And Jan and I are now thinking about an experiment whereby we're going to teach Furhead medical information. So we know that in a consultation, patients only remember like about 10% of all the information. And there's a really need for repeating the information, thinking about it and asking about it and talking about it again. And we thought maybe Furhead may be used for that because he's very patient. He will repeat the same information time and time again if you want him to. So we're going to see if following a regular consultation with the doctor, if you have a second consultation with Furhead, you're able to ask, what exactly is this diagnosis? What exactly is this treatment? Can you tell me again? Maybe this will improve the quality of the care that's being given. So these are some of the examples of BMS technology experiments that have been done here in the lab, which we are taking outside into the hospital. If there's anything you feel interested in, if you think, oh, this is something I'd like to follow up, or maybe you want to meet other doctors or nurses, want to do experiments with patients, whatever, at the hospital, you can contact me. I'm in cubicus B131. And if I'm not there, you can send me an email and we'll talk about it. That's it. Any questions?
Do we have any questions from our audience? Okay, then I think we can continue then. Thank you, Harold. Thank you. Harold mentioned about social robot forehead that some of you might know, and you can actually experience it yourself talking to forehead today in one of the rooms in our demo market, and also walk in nature. Jordi, our colleague, will tell you a little bit more about it, and you also can experience yourself the yoga exercises, catching the butterflies, everything that the patient of Harold already did here. Okay, now we are moving on to the second amazing speaker, Tane Herbout. Sorry for my pronunciation, I asked before. I hope it's okay. So thank you for being here today, and please take the stage.
Thank you. Hello everybody, I will introduce myself shortly. I am Tane Herbout and I work for Transfora, which is a mental health provider for forensic patients. And they focus on the east of the Netherlands. And I work here for 4 years looking at implementation of technology in care. And this year I'm looking at how to implement wearables in aggression regulation therapy. So I will tell you something more about this. But first a little bit of background, where does this come from? Some therapists at Transfora have started experimentally using wearables in their aggression regulation therapy, but they didn't really understand how to implement that, how to structure it, because they used it like, oh, this might help, it gives you insight in your stress level, so good luck with it, use it. And patients were like, how am I supposed to know how this is working? So they lacked a little bit of insight in how does this work and how can we implement this in a better way. As you know, wearables measure several physiological variables like heart rate variability, skin conductance, and these measurements of these variables correlate with negative emotions such as stress and aggression. Research shows that for forensic patients, that 20 minutes before they have an aggressive outburst, you can already see changes in their physiological variables, so that their heart rate is going up and that their skin conductance is changing. So you can see it way before it's already happening, but the problem is that they don't feel it. Using heart rate variability as a biomarker can also improve self-control, emotion regulation, cognitive flexibility, and also has a positive impact on anger and aggression. So this has implications for treatment practice, because if you have insight in your bodily signals, you can also apply the right coping skills at the right time. So this might prevent aggression, or they know how to deal with it better. So wearables offer patients a new way of getting insight in their bodily signals, and it's also a new way for them, a better way, because it's experimental. They can experience how it works in their home-based setting and not only in a room with a therapist. So it shifts the treatment from episodic short-term treatment to long-term continuous support. So they can also practice with challenging situations at home. That is where it mostly happens. So the goal is now to integrate wearables in a customized aggression regulation therapy. I will tell you something more about this later, but this is really the background where it comes from. It's really a question from practice, not really from science, so it's really good that we can really make a difference for patients and practitioners on the floor right now. The research questions are: what are advantages, disadvantages, and areas for improvement when it comes to implementing wearables within aggression regulation therapy, and how can they be integrated in group or individual aggression regulation therapy, and what are potential underlying mechanisms of wearables. The setting for the project is that I work for Transforum. We work with a small group of researchers, and we do this project together with V4. And V4 focuses more on the west side of the country when it comes to forensic care, and we do it more on the east side, so we're widespread across the Netherlands. University of Twente is involved from the Department of Psychology, Health and Technology, and the founder is Kwaliteit Forensische Zorg. Boring. Next. AR op maat. This is the intervention where it's all about. AR op maat is a aggression regulation therapy that can be given in group sessions but also individual. In Transforum we do it in group sessions, and it consists of 11 modules in which the patient can practice with stress reduction, coping skills, and so forth. Also they take a look at the network, at partners, so it really treats the patient as a holistic individual. And they also do drama therapy in the sessions, so they do role playing, and that is where the wearable really is useful. For the project we're using the Garmin Vivo Smart 4, but there are a lot of other different wearables that can be used, but we chose a smartwatch because that's easy for them to use. It's a small thing and it's easy to use, comfortable and accurate. So it was also chosen by the therapists themselves. Well, this is also the app that comes with it, and here you can see how it looks when you look at your stress levels during the day. So the blue stripes, that is when you are at rest, and the orange and well, red is not really visible, it's when you are really stressful. So this is what the patient can look at when it comes to stress, and also the watch gives notifications when your stress level is mounting. So it gives this message like you need to calm down, can you do a breath exercise? So there's a relaxation exercise on it which you can do. The research design, very short. We do a first pilot that is started by the therapists in Transforum. It's an ongoing pilot. We did a desk research and focus groups in the second pilot. But I will start with this first pilot. As I already told you, it is an initiative from the therapists themselves, wherein they use the Garmin Vivo Smart and ambulatory AR op maat. We formed a project group with the practitioners together with the researchers to structure the use of the wearable a bit more. They used it in a very unstructured way in the first pilot to look at how can this work and what are the first experiences. So we did interviews with patients that have used it already to identify requirements. And what the first results were that they were really liking the possibilities, but it's quite much because it's a smartwatch, so it's a sports watch. It gives you all kinds of notifications. Also, when you met your goal of steps today, like good job, you did your amount of steps. Here you have a badge. Or you get a phone call. There's a message from childcare. There's all kinds of messages that you can get on this watch, and that is overwhelming for most patients. Much of that is good to overcome with guidance and settings changing. But most of the requirements are quite simple. It has to be accurate, it has to be easy to use, it has to be comfortable to use, really easy things to, because for them it has to be low-key. With this input we went on with desk research. We're still doing this desk research to check if there are other wearables that are suitable for the patients to use in the treatment. So we're now testing the Fitbit Sense, the Now Watch, or maybe you say No Watch, I'm not sure, because it doesn't really give any input on the screen of the watch itself. There's also the Hume sock that we wanted to test, and the Garmin we're using now. So it's still going on. Therapists are still using it to check if it's suitable, but it takes some time. You know, therapists are very busy people. So we decided to go and continue with the Garmin Vivo Smart 4 because they know it already, and there are positive experiences with it. We did focus group also with therapists to check if how and when to deploy the wearables. and we've decided to apply it in the stress reduction module. There are 11 modules that we want to integrate the wearable in, but we have to start somewhere, so we thought stress reduction really fits the purpose of where you want to use it for stress reduction. So if you have lesser stress, it's about reactive aggression. So if the stress is lesser, then you can prevent aggression. And also what is needed to deploy wearables in our mat. So together with the therapist, we adjusted the manual a bit, because there is a manual for our air mat in which they describe which exercises can you do. And we wrote some parts about how you can integrate the wearable in it. So there are exercises, for example, about how to calm yourself down with music, bring your own favorite music to the session, look at your heart rate, how does it change when you listen to your favorite music, or another is to sit on a balloon. So the problem with forensic patients is that they don't feel what they're actually, what's going on in their body. So they say my aggression, it went up from 0 to 100 in just 1 second, but this is not really the case. So they have to experience what it's like, how does it feel when you get stressed. So that's what they do in role playing, or with exercises, go and sit on a balloon. Or last time I heard in an interview, a therapist said I did a bridge exercise, so you have to pass each other on a bridge, and the therapist is challenging the patient on a way that can arouse him a bit. So they have to pass each other on the bridge, and they have to deal with that with each other. So you can see really, and they look at the watch, say, how do you feel? Do you feel that your stress is going up? What does your heart rate tell you? It's quite easy to do that. And also they, normally when the patient came back from home and they went to a session with the therapist, how was your week? She asked. Well, it's fine, nothing happened. I think it went fine, but it's also very hard for them to look back and see all the details. You don't remember all your stress moments during the last week. So this really, the graph I just showed you, you can see it on a weekly level too, so you can perfectly see which days were stressful for you. You can click on them and which moments were stressful for you. How did it come? It helps also to already look at the week ahead. Are there moments where you are challenged by life? Are there moments where you expect to be stressed? Difficult conversations with your partner, for example. So this, you can really look ahead and look back and have a way of talking about the stress in another way, make it visually. Oh yeah, we did also adapt the default settings of the wearable, because it's a sport watch and you have all these kinds of notifications coming in. That was too much, so we changed it a bit to fit the purpose of our mat. So we only use heart rate variability, heart rate. The body battery was on, and sleep, we measured sleep too, and the stress level. So there were 4 things they can look into, and the rest was off, because that was really not the purpose. Together with the therapist, we set up a new pilot to check if there were any changes if we did it in a structured way. So if they did the exercises together with the patients. So we did a 5-week research, and in these 5 weeks we measured how they were doing with the Etica app, which is Experience Something. So they got twice a day. They got questions about how are you doing, and we measured aggression, interoceptive awareness, self-control, and regulatory emotional self-efficacy, which is how can you deal with negative emotions, can you cope with them. In these 5 weeks they did this experience sampling, but only in weeks 2, 3, and 4 they used the wearable. But the first week was more the baseline, and in the last week was more the follow-up. We did a pre and post measurement with these questionnaires I mentioned on the sheet. And we're still in the midst of the second pilot, so I cannot share very much of results yet. But the first lessons learned I can share. They are very positive about the wearable. Some of them say they cannot go without anymore. They're really holding on to it because it really helps them get insight in how they feel. But some of them don't really like it because it's on their wrists, and for forensic patients, something on their body really feels like they can be tracked. And in 5 weeks, it's really too short to see any effects on interoceptive awareness or self-control. This takes more time, so we didn't see in the quantitative data, we didn't see it back, we see no changes. But in the interviews, they gave back that they really did feel different, that they could apply the right coping skills on the right moment, step out of the situation when you are stressed, or do a breathing exercise in the right moment because they got a notification that they were stressed. So there are differences between qualitative and quantitative results, but I think when you take more time, and you see that already when patients that are further in their progress, that the wearable really adds something for them. When they are not really far in their progression, they are mostly very critical and they have resistance. They say things like, the wearable gave a message, I was stressed, but I don't feel anything. This can't be right. It's not measuring well. So they blame the wearable instead of looking at themselves, and that is the process they need to go through. For the therapists themselves, how do they feel? How do they implement it? They said they needed good guidance and intervention for themselves. So together with a group of therapists that really like to work with the wearables, they formed a working group for intervention, and also to discuss how to deal with this resistance and how to deal with the group if a few of the group want to use the wearable and others don't. How do you use exercises? So they really want to have the guidance, and we are still working on this to get it better and make the implementation materials better. So this is really the first lessons learned. We're still in the midst of it, so if I were a few months later, I could tell you a lot more, but this is really what I'm working on. If you have any questions, shoot.
You're mentioning that you also measure sleep. There seems to be a correlation between sleep and aggression. Are you looking into that part as well in this research?
No, not for myself, but the Garmin measures sleep. So for forensic patients, most of them have a really complicated, mixed up day-night rhythm. So for them it's very informational, but for me I don't look for it. No, I'm not measuring it with questionnaires.
What is the long-term goal of this intervention? So is it the idea that they continue to keep wearing the watch for basically as long as they want?
Mm-hmm.
Or is it really just to train them to learn their own stressors?
Yeah, they can use it during the treatments. So as long as they are in treatment, because the watches are transferable, when they're finished they have to give it back. But that's why we chose an affordable wearable, because this one's not very expensive. So if they want to buy one of their own, it's easy.
Yeah.
Yeah.
But because I can also imagine that there would also be continuous self-management help.
Mm-hmm. It is, yeah. It is. That's the goal indeed. That they, well, some of them really want to keep using it, but it would also be the best if they were to feel it by themselves without the wearable.
Yeah.
Yeah. But it's really a trust issue because they don't trust their bodies. They've never felt what's going on, and it's also a process. So we have to look at the long-term effects in another study. It's too much for this. All right. Thank you very much.
Thank you so much. Nice. We had some questions, so I think the audience warmed up a little bit. That's good to see. Yeah. So thank you, Tanya, for the insightful presentation. I think it's very interesting. Also, as you might see, Tanya is our external guest who came. How many hours did you travel here? Not so much. Okay, that's good to hear. Okay, and yes, our last speaker, excuse me again for my pronunciation, Simon Langener. just a few seconds to arrange the presentation. And yeah, while the arrangement is happening, I would like to tell you that here in the demo market you can actually try not the same wearable that Tanya used, but Embrace Plus, and you will be driving in a driving simulator, and you will see if your stress level is going up or down. So maybe not good drivers should try it to see the stress level going up. And of course, also our team app, my colleague Theodora also will have one of the demo stations today. And this is in-house application that also helps you to measure different variables in a natural environment. So Tanya was also using another app when there are questions popping up. So our team app does a similar thing. So if you want to know more about it, if you want to use it in your research, Theodora can help you with that today. Yeah, let's continue.
Thank you very much for having me here. So I will talk today about the Tactus Alco Refusal Training, which we call TART. And I want to specifically talk with you about designing influential virtual agents for peer pressure simulations. So it's a part of this project, and I hope to inspire you with it. So to my person, I'm Simon Langner. I'm a PhD student at the Department of Human Media Interaction here at the University of Twente. And I almost finished my 4 years as a PhD student, and I already started my new position as a postdoc at the Radboud University Medical Center, Department of Psychiatry, to continue doing research. During my PhD, I focused on immersive virtual reality applications to treat substance use disorders in people with lower cognitive functioning. So for example, people with LVB in Dutch, so licht verstandelijke beperking, or mild borderline intellectual disability. And in the next project called Detox at Home with the Radboud UMC, we are trying to develop a detox platform for people to do it at home. So there's telecare and telesensing involved, and we try to improve this by using tech at home. So during today's presentation, I would like to briefly look into the development of TART, and then I would go over to peer pressure agents, understanding mechanisms and user experience, and then I want to talk about the future, because for me it's very hot and new topic, and I'm interested in your views about it. So let's start with the development. So we developed TART, the Tactus Alco Refusal Training, together with experts at Tactus. We had a few pilots before with virtual environments, so we understood that we can induce cravings by showing, for example, cigarettes or showing drugs to people with an addiction problem. So people react quite realistically to cues in the virtual environment. That's nice. But what can we do with this? So we can measure it, we maybe can find algorithms to diagnose healthy from dependent people, but what can we actually do with these cravings? And we think it's very limited. So it's a symptom you should experience, but we think that the major part of a virtual reality therapy in terms of in the domain of addiction lies in cognitive behavioral therapy. So we need exercises to train different behavior, which informs our cognition and vice versa. So what we did is we invited actually 5 therapists from Tactus to co-creation sessions, and in the first session you can see we were a lot talking about the virtual environment. So we specifically asked them, okay, what do you encounter in your daily practice? What do people tell you? Where do they relapse in social situations, and so on? And from here we collected ideas. We also in the second focus group really asked them for a given situation to draw virtual agents, how do they look like, what properties do they have. I heard a lot of tattoos and other things, right? And then also we looked at the persuasive dialogues. So what are typical things people with an addiction hear in such a social setting, like, oh, come on, don't be so boring, we have a nice evening here, come grab a beer, come on, don't be so boring, right? Something like this people will hear sometimes. From here we started actually developing the prototype. So this was really just working behind my computer, developing the scene that we developed together here, kind of cognitively. And then we actually also had an expert evaluation to try this prototype with the therapists and to get their feedback, for example, to understand accessibility problems and so on. And quickly to the next slide, I know that a few people from Persuasive Health Technology are certainly here. So we also followed the persuasive system design model as a framework to design for influence, essentially, and to understand also what kind of influence our users encounter. So we have, for example, a virtual agent has a social role, simulates an interpersonal relationship in all of this, but we also have social facilitation, people sitting there just drinking, it's a social cue. We have normative influence, and I will come to this later, and all the other primary task support features. And interestingly, what I think is interesting, we put a user interface into the 3D environment, so we can tunnel actually the user through the dialogue with the virtual agent. Yeah, you can see it here. That's the environment. You can see here all kinds of cues, right? You can select the music that is there. You can select if there's smoking supplies. You can select the amount of objects that should be present. And also what we found is very important are maybe two major outcomes after the expert evaluation were, the first thing, we need a form of storytelling immersion. So we want to bring a person from A to B, let's call it B, the end of the intervention, but we don't want them to feel like it's an intervention, right? We want the feeling of flow, and we want them to enjoy the experience. So we kind of built a little story around this, where you are invited by your friend to a party this evening. Then from this room you go to your dressing room. In your dressing room you can select hand colors, you can dress yourself, you can select music, hip-hop, electro, whatever, and can then join the immersive experience again. It's really sort of tailored to you as a person. And in this environment, let's see. So it's highly interactable, so you can, for example, play darts, you can open the fridge, which makes it, in terms of cue reactivity, quite realistic. And we are also including other measures, so I've heard now smartwatches, we try to also measure heart rate while people are in this scenario, or going through this scenario. The second big point that we learned at the end of the development with the experts is that artificial voices do not contain the emotional information we need to persuade people. So we needed real actors. Actually, we asked 10 actors to record the dialogue for us, and we did run a speech analysis on these recordings and try to identify two different types of where is it? I will go back and forth a bit. So we were interested in how can we design an agent that is now influential, because there is in this voice, there's emotional information, and we need to convey this to change behavior. So we were asking us, okay, what kind of models are used to actually build agents? And one of the most prominent models is the interpersonal circumplex model, which has two axes, an agency and communion axis. And in case of a peer pressure scenario, we think that you're in the dominant part, and we can do it once friendly, for example, in a way of doing banter, right? Laughing with each other, about each other a bit, like in a funny manner. Or we can really be hostile and say like, what are you doing here if you're not drinking? You go home, right? So, and that's what we did. And implemented 2 different voices. And then we did a user study. We involved in total 20 patients with alcohol use disorder from Tactus and their therapists, so they were doing this together, this experiment, to understand these mechanisms and if the ideas we have actually really work in practice. And here you can see our idea was to design a hostile and dominant hostile and I made a mistake, I guess. Anyway, it should be dominant hostile and or dominant friendly, the personality. And this is actually the self-report data after the interactions by the participants to kind of plot where we are in this area. And we see that they fairly rate the agent as dominant, almost always, but they cannot differentiate between the friendly and the hostile stance of the agent in interacting with the user. So when we see this as a manipulation check, we could say, okay, the manipulation didn't work, but we also know about the target group a lot, right? So people with lower cognitive functioning, they might have issues in processing social signals. They might have difficulties also in their history, that they have a background of bullying and so on in school. So they might be affected differently by those agents than other people, because the higher the intelligence level became, the more people were able to find out that one is hostile and one is, it's not statistically significant, it's just an observation from us, nothing that is proven. But anyway, so we asked them about the persuasiveness of the agent group, and also the power of the agent, because you need to understand that this is a computer program. It doesn't have any power per se. We attribute power to something. And if we perceive this agent as not powerful enough to give us any, let's call it advice or influence, then we won't accept it. We won't change our behavior. We won't reach dissonance in our mind, right? So, yeah, what we found is that they rated the agent pretty high with persuasiveness for both conditions, the friendly and the hostile. They even rated the agent group as persuasive, though the other 2 agents, which we call background agents, weren't doing anything. They were just there, right? And the idea was after that, like, hey, they could form a team against you, but there could also be a supportive agent in between them. So we can simulate kind of, okay, how would this scenario be if somebody helps me in this scenario, right? And then we also look at other user experience characteristics. Like I said, we know that in this environment there's reactivity, and we saw also here baseline almost no cravings. Later the cravings develop but stayed on a good level, at the end still high. But way more interesting is anxiety, because anxiety was already at the beginning a bit higher and became even higher during the interactions with the agent. So, and from a psychological perspective, when you're in a peer pressure situation, right, and you have in your mind the attitude, hey, I want to stay clean from alcohol, I don't want to drink today, right? And then you are coming to this social setting, and this setting gives you the information, hey, you should drink. So then you have a contradictory information here, right, which we call dissonance then. And what often happens in people with an addiction is that there is an attitude shift towards drinking. They just, in this social situation, they give up their attitude, they just say, okay, we go on with a drink. And then they are back at the start. So, interesting, eh? Why am I showing this slide in combination with peer pressure agents? It's because I think, and this is also how I want to inspire you in some way, I think that peer pressure agents are already there and they will influence us all. And we have, for example, things showing to like ads for incels on Reddit, right? So you can get AI bots there. They build a romantic relationship with you, right, based on machine learning. So you may get addicted to a virtual bot. You might spend money on this. You might even maybe she at a certain point says, hey, you know, you look way better with this clothes from Amazon. That's certainly influential when you have a relationship with a virtual agent. So I want to make you all aware that this is certainly a problem that is incoming, and that at a certain point people will invest tons of money in these kind of artificial women, like they now do it on OnlyFans or other platforms, right? So about the future work, let me look here. So in general, I was shocked that there's really not much work on it. So we are pioneering this, definitely. So way more research is needed, especially to differentiate also informational influence versus normative influence. So when you have a counseling virtual agent, right, this mostly provides informational content. So at the end you can say, okay, what the agent is saying is right, it's true, so I should stop smoking and then I will get health benefits from it, right? That's information influence. You can really say it's true, but normative influence is emotional influence. It's how is it often called? A logical fallacy, right? It's connected with an emotional argument which has really no real, how to say it, fundament, right? So it just influences you in your way. You shift your attitudes, or should shift your attitudes. Then also the question, how can we educate and protect people from influential agents with bad intentions? So in this case, we're doing this on purpose for people with an addiction. We try to teach them coping strategies, and in the end, they mostly leave the room and are very happy about what they discovered in this session. And most of our patients, also very interesting, need aftercare. So they are so done after this experience, after their cravings, after this pressure and so on, they often go to sleep or apply coping strategies actually. People with an addictive disorder function as a preconditioned target group to study the underlying mechanisms. So it's a very special target group because they are preconditioned for this exactly case, and you don't have it always, like for example with the AI chatbots, you don't have this. So it's a very nice case to study also the chances of influencing people. Yeah, and the last question is, how can we use it for good? Thank you for your attention.
Questions?
Yeah, please.
Hello, thank you for your presentation. Can you hear me? Yeah, I guess so. Very interesting. I have many questions. I'll focus on two for now, I guess. I'm sorry, it's very much my topic, so I'm very interested. So first of all, very interesting. You said that you did co-design with therapists, right? Or like subject matter experts. Were you thinking, or have you done any co-design with actual patients as well?
Yeah, we started our project with co-designing with patients, but you know the MBID group, like the lower cognitive functioning group, it's really complex to co-design with a small n, and they are hard to reach. And you always need to see like, okay, what kind of burden do they get in testing, in developing? So we focus more on the testing actually to be a burden then.
Yeah, this is fair enough. Like ethics is also a bit larger topic. Okay, next one. Have you thought about the uncanny valley effect at all with the virtual agents? Because I found it in my own research. I don't know how it influences it, but I found it very interesting too. So I chose non-humanoid characters at some point because I had issues with.
So a few students also looked into this, but till now it's really just that we
The environment, like how would people get around, like just locomotion-wise, interacting with the
locomotion-wise,
environment?
yeah. So for locomotion, we decided for teleporting to anchors on the ground. We have a very limited environment. So first we had, during first prototypes, we had way bigger environments with, I would say, more options. But in a sense, that's not true, because you should limit it to a smaller space, make it more interactive, make it more realistic, and then people will become immersed. And that is also, when you take a step back, and we are going again to this motivational question, right? Why are people using tech to improve conditions, etc.? It's not about motivation, and that's what we want to achieve by throwing darts, whatever. Can do almost everything.
And they had no issues with the interaction itself, or?
No. To be fair, we did run before a study focusing especially on the interaction system. So that was already tailored for the school. Yeah. You're welcome.
I think our screen's already telling us that we need to move on to the next part. Thank you. Let's give. Actually, Simon didn't mention that today he also showed a demo that you can actually train your alcohol refusal there in XR1. So please be my guest. But then we have drinks at 4:45. So please first train and then come for the drinks. And could we invite our speakers just for a moment here to express our gratitude, and yeah, we have small gifts as a thank you. Can I invite you, Harald, Tony? Yeah, so you come back. Thank you. No, it's okay, a round of applause. Thank you. So now is the second part of our event. As I mentioned before, there are some maps you can find there, and also maybe let's place the map here. As you might see, there are two workshops. A Figma workshop actually is right here. The doors will be opened in a minute. 15 people maximum for one round can join. We have Unity workshop. Please follow the signs, and also our student assistants will help you. Each workshop is 45 minutes. And thank you, the Interaction Lab, for organizing it. It's not our part. Interaction Lab the second organizer here, so they will help you out and explain you how to proceed. And the demo market, as I mentioned already, the social robot that Harald was talking about, the wearable and the driving sims. So a lot of things you can see today from the presentations already. Hopefully you got inspired, so now you can go and experience it yourself. The signs are everywhere, so it should help, but if you don't know where to go, please ask people with BMS pages. Yeah. Okay, thank you. Have fun, and please come back at 4:45 for networking and drinks.